Okay, in this podcast we're going to take a quick look at Lewis acids and bases, which are important in organic chemistry, but we just want to make sure you can identify what is a Lewis acid and what is a Lewis base. So Lewis acids are electron pair acceptors, and as you can imagine, Lewis bases are the opposite. They're going to be electron pair donators. So let's just take a quick look at an example. Which of these two, BH3 or NH3, would serve as a Lewis acid, and which would serve as a Lewis base? So if I just think about what we have here, we have BH3, and if we draw the structures, we can see what's going to happen. So boron has 3 valence electrons, hydrogen has 1 each for 3, so that's a total of 6 valence electrons. So if you remember from the bonding unit, boron is one of those elements that can violate the octet rule because it is so small. So it can only hold 6 electrons, and that's okay, right? It's a valid exception. NH3 is opposed to that. Nitrogen has 5 valence electrons. Each hydrogen has 1, so that's 3, so that's 8. So NH3 is going to be this structure with a lone pair of electrons. So which of these two can accept? This is going to be my acceptor. That's my Lewis acid. This has a lone pair of electrons, which it will donate. This will be my Lewis base. Okay. Alright, so here we have the two. Actually, we have BF3, but in fact, BH3 and BF3 and BCl3 will all act the same, just like NH3 and F3 and Cl3 will all act the same on the nitrogen side. What will happen with these is they will form what's known as a coordinate covalent bond. And when you have a coordinate covalent bond, what you have is you have one of the atoms donating both of the electrons to the other. Okay? So these will end up being shared, but they both come from the nitrogen. And sometimes this coordinate covalent bond is drawn as an arrow. So if you see that, that indicates you have a coordinate covalent bond and both of the electrons came from the nitrogen. Okay, so in this case what happens is the nitrogen here in the ammonia donates the electron pair to make the bond with the fluorine. Okay, so most questions on the AP exam will give you a list and ask you what's going to be the acid and what's going to be the Lewis base. One thing you should know is that any Bronsted-Lowry base, which is it's a proton acceptor, also acts as a Lewis base. Okay, so you should memorize that ammonia type structures with the lone pair here are always going to be Lewis bases. They have these electron pairs to donate. And structures with boron, where it violates the octet rule and is minus this electron pair, is always going to be a Lewis acid. So let's take a quick look. Alright, so I have PH3 and BCl3, which is going to be acid or base. Draw structures as proof. Alright, so I have phosphorus. It's going to be just like NH3, right? Phosphorus has 5 valence electrons. Hydrogen has 3 within its 3. It is going to have this structure. It definitely has this lone pair, which is available to donate, so this is going to be a Lewis base. And BCl3, now let me see, boron has 3 valence electrons, chlorine has 7 each, times 3 is 21, that's a total of 24. Give all these chlorines a full octet, and when I do that, there is nothing left, so it's 8, 16, 24. It is short electron pair, so this will be a Lewis acid. Alright, we're going to